Hi everyone, in this video I will show you how to define your own objective function. So in this case you need to write an R script to define your own objective function and tell RSWAT to use this script to calculate the objective function. And for this example, let's say that we want to extract stream flow from two ridges, 1 and 3, and we put more weight on stream flow simulation from ridge number 3. So our objective function look like this. So 1 times NSE of Q1 plus 2 times NSE of Q3. And for how to get example for this video, please see tutorial 1. So now let's open RStudio. Library RSWAT, and then show RSWAT user interface. So we should do everything as usual. Here my working folder and take in take out folder of squad. Here in my squad executable file. Here squad executable file and my parameter file. Squad param, so I accept everything as default, just one simulation. Run squad, I want to extract output from ridge number 1 and 3. Column number 7 is the stream flow. So you can check your output.rch file and you will see that the column number 7 is stream flow. And okay, everything is default. Now I run SWAT. Simulation was done. Objective function. Now I want to have my own objective function. And for this objective function, I need to maximize. Higher NSE is better. So I need to create a user objective function. So let's open RStudio, new script. To get template for this file, you can go to a SWAT website and then go to user objective function and copy from line number 40 to 132. Copy, paste here. So, and I save this file with this name. Must be saved with this name. File say as, you can say anywhere. So I save the example. Must be with this name. So we have two outputs here. Let's open RStudio. Here you can click here. So the first variable is stream flow from ridge number 1, and our second output variable is stream flow from ridge number 3. Yeah, so the information is here. And here's stream flow from ridge 1, observe stream flow from ridge number 3, and simulated stream flow from ridge number 3. And we are only allowed to modify from here. So from here to here, I have removed all of missing data in the observe files. So now we and the corresponding simulated value. So now we have very clean observed and simulated data. So we are only allowed to modify from here to here. Let's say our output is, our objective function is NSEQ1 plus 2 times NSEQ Q3 divided by 3. Yeah. So the NSE of Q1 should be equal to 1 minus sum of the, which is observed here, minus sim related here, square divided by sum of observed minus mean of observed square, and so on for reach number 3. But here reach number 3 is the output is observed 2 and sim 2. 3, 2, 2, 2, 2. This is for reach number 3. So I just say NSE of the first variable, which is reach number 3, reach number 1. Here, NSE Q3. Assume that if you want to calculate NSE for other region here, you should copy this and do similar. But in here, we just do for 2 regions. So our final objective function, you are not allowed to modify this name. Yeah, the final objective function is NSEQ1 plus 2 times with NSEQ3 divided by 3. Okay, we are done. So don't modify anything after this. Save and back to our user interface. We need to load that file. So here I load that file. And now let's assume that we have this here observed from reach 1. Just copy and paste. Assume that this is stream flow from reach number 3, but because we just have 2 variables, so the name should be continuous from 1 to 2. Just an assumption. Okay, now load observe file. Examples 1. Here we just have 2 files. You can click here and see that the value are identical. Yeah, we just assume that simulated value from bridge 1 and 3 are identical. And now calculate the objective function, and then can display the objective calibration, and for each variable NSE of reach 1 and NSE of reach number 3 during calibration. So we can validate this by using Excel. Now let's calculate again the NSE for calibration for each ridge. So here I'll observe data here. So key observe of ridge 1 and 3, we just assume it identical. And our simulated value is in working folder. I'll put this Q simulated from ridge number 1. I say Q sim Q1. This is simulated stream flow from ridge number 3. Sim Q3. Sim Q3. Okay, just remove this, delete. And now I sort data filter according to this, because I just want to, this is missing, so I can delete it. I just want to calculate for calibration here up to here. Delete. Okay, now I calculate the NSE of Q1 during calibration, NSE of Q3. But I need to calculate the mean of Q1, mean of observe of Q3, mean equal to average. Here, 1, 3 are equal. Yeah. So this is Q observe 1 minus Q simulated square Q1 minus this square and Q1 minus mean Q1 Q1 minus this need to fix the position square. Okay. And so on. We need similar for Q2. Sorry, Q3. So Q3 is also here. Minus square and Q3 minus mean Q3 square. Need to fix this one. Okay, NSE now equal to 1 minus sum of this divided by sum of this. 0.05. This is 1 minus sum of this divided by sum of this. So here our NSE for calibration, just round up 0.0 minus 0.55. You can see here for calibration for Q1, the NSE, and the NSE for Q3 during calibration is 0.007. And now overall objective function is equal to this plus 2 times this divided by 3, 0.2028. So 0 here, our overall objective calibration is 0.028. So we have done correctly. Yeah, thanks for your attention.